This is question 1. I have put in the coordinates for the point A at pi over 6 negative 2. Pi over 6 is a nice angle, and that's something that should attract your attention when you see it, remembering that pi over 6 radians is 30 degrees, and it has some nice exact values for the sine, cosine and tangent. So let's tackle part A. And we know that when x is equal to pi over 6, y is equal to negative 2. And we're going to substitute those two values into the equation for y, which gives us negative 2 is equal to 1 plus k multiplied by the sine of pi over 6. So that should be ringing bells with you, and you should be thinking sine of pi over 6 is the sine of 30 degrees, which is 1/2. So negative 2 is equal to 1 plus k over 2. Multiplying through by the 2 gives me negative 4 is equal to 2 plus k, and therefore our value for k is negative 6. For part B, I'm now going to rewrite the equation with our value for k in there. So the equation is that y is equal to 1 minus 6 sine x. And we're looking at the behaviour of that curve from 0 to 3 pi radians. The point B on our curve is the maximum point of that function. So we're going to consider what the maximum value of this is and what value of x is going to give us the maximum value of the function. It's important to be thinking that the sine of x can vary between negative 1 and positive 1. So y will have a maximum value when the sine of x is negative 1. And if we put that in, we get that y will equal 1 plus 6, which gives me a maximum value for 7, which is the y coordinate of the point B there. And of course here the coordinates of this point B are A and B, and that's what we're looking for. So we found the y coordinate of that point. In order to find the x coordinate of that point, we need to know what value of x is going to give me the sine being negative 1, and the value of x that gives me the sine equal negative 1 will be 3 over 2 radians. So our value of A and our value of B that we've just found are 3 pi over 2 and 7.